Hello guys, this video will be talking about linked list. So linked list is one of the most important topics which comes in a data structure. So most of the interview questions too will be based on this one, and not just this one, but of course it's one of the important topics. All right, so let me draw a few notes for you. All right, so linked list, like you might be knowing about array. If you don't know what array is, please refer arrays and then come back to linked list because without knowing what array is, then it will be hard using this video because like I'll be talking about arrays a lot. All right. So when we use array, like the memory which we use in array is continuous, and we all know about that. But coming back to this linked list is just like like a data will be stored in one particular place, and the other data will be stored in some other place. Let's suppose like one data is in India. Let's say this guy is in India. All right. So the other guy is somewhere in Australia. So it doesn't mean like these guys will be close to each other or something like that. It's not at all like that. It'll be randomly stored. But you know what? Each and every node will be knowing its very next node. Only its very next node. All right. Let's suppose this is node one. All right. That is India. So India know its very next node, which is Australia. Where is this guy? So India knows where Australia is, and Australia knows where the next guy is. It's something, let's say, like US. All right. So only Australia know there is someone called US, and also he knows where it is. All right. India will never have a clue about US or some other people who comes after US. All right. So the linked list concept is like every node will know its very next node. So node 1 will know who where node 2 is, and also like whether node 2 is available or not, because like sometimes the current node will be the dead end. All right, it's just like your train, like in train, like each and every compartment it's attached, and you can further attach whenever you want to attach some compartment. You're most welcome, right? It's not like you're supposed to attach only at this particular portion. That no, not like that. You can keep attached things. All right, so let's say this is your head. All right, and one linked list will be having only one head. That is the very first node of the linked list. That will be also called as head. All right, so the head will know the very next node, that is node 2, whether it is available or not. If it is available, where it is. So that is of node 2, and node 2 will know where node 2 is. All right, and node 3, according to this example, node 3 will know that there is no other node beyond this, that this is the last node. All right, but only this guy US, that is node 3, only knows that he is the last node and there is no other node beyond this. All right, so look at the nodes. Like, why am I calling that as nodes? What does that mean? Node means it's just like a storage. All right, so every node will be having two data, which is really important. Two data, that's the minimum data you should store. That's like something which is mandatory. So one thing, one storage you'll be using to store the data. All right, so of course we'll be creating data structure to store some data. That is a basic use of having the data structure. All right, so the data, you can store any data. You can store any data, like it can be integer, string, or whatsoever data you want to store. You can store it, no problem, but you have to define it. You have to define like what type of data you're going to store it. All right, let's suppose I'm starting with integer. I'm going to store integer. I'm going to store 3, 7, and 1. All right, so what I have to do is 3 should be stored here. All right, because 3 is the very first thing which I'm going to store, so 3 will be stored in the node. All right, I already told you your node will be having two storage, one to have the data, and we have done with the storage of the element, that is actually 3. So next one, what about the next one? Next one, as I told you earlier, next one will have the address of the next node. Let's suppose the address of Australia will be here, because I told you first one is India, second one is Australia, third one is US, right? So first node will have the address of the next one. All right, so I'm going to clear all these things now. I'll make a fresh diagram. All right, so what I'm going to do is like I'm going to go step by step. All right, now I'm going to store 3, 7, and 1 as I told you. So first I'm going to create 3. So one thing in linked list is like head will always focus on the very first node. Initially in the sense like when you have nothing, I mean, like, when your linked list is empty, head will be null. All right, because there is nothing. If there is no head, obviously there is nothing beyond that, because I told you head is the very first node. If there is no first guy, obviously no second guy. All right, so head is equal to null for the very first time, which means your linked list is empty. All right, when I'm going to store tree, what I have to do is like it's a general thing. It's not like only when I'm going to store the first element. Whenever you want to add one element, what you have to do is like you have to check the head. All right, now look at the head. Head is null, which means like your linked list is empty. So what you have to do is like you have to create a node. All right, whatever it is, like you had to create a node. Whenever you want to store something, definitely you need a node. All right, you cannot merge two elements into a single node. No way. All right, whenever you want to add something, you have to create a node. Whether your head is empty or not, whatever it is, you have to create a node. So I'm going to create a node here with 3 as my storage. I told you like you'll be having two storage. One is of type integer, the other one is of type node, so that you can store other node, right? As I told you, the second storage is to focus on the next node, so it should be of type node. All right, so initially whenever you're creating a node, the node type, let's say this is value, integer value, and this is node next. All right, so you have two variables, one is value of type integer and next of type node. So value is 3. Obviously whenever you're going to create a node, you will be having a value, so I gave the value as 3. And coming back to next will be null by default. I say by default, whenever you're going to create a node, you'll be storing the value and your next will be null by default. All right, so now you created a node. Let's say this is temp. You just created a node called temp is equal to the entire compartment, that the entire node, all right, which contains 3 and null. Now first thing you have to check whether your head is null or not. To you should know the current status of your linked list, whether it is empty or not. So I'm checking my head. Of course my head is null because I haven't stored anything before. This is the very first element which I'm trying to store into my linked list. So what I'll be doing is like, if my head is null, simply say head is equal to temp. What is temp? Temp is nothing but the node which we just created. All right, so since there are no elements in your linked list, you're making the current element as your head. So now this will be altered as head is equal to the node which we stored here. Let's assume that address of that node is 1. Just assume. All right, so this is your first node. So now you're done with insertion. All right, you're done with the first insertion. Okay, let's clear the insertion. So as for now, one thing you should remember, your head is equal to the very first node. Very first node is nothing but, I'll put it there. Your first node contains the element 3 and the next is null. As for now it is null. Alright, so this is your linked list. So far you have created something into your linked list and this is a 1. Alright, this is a 1. Alright, so now you're going to add one more thing. You're going to add 7. As I told you, whenever you want to add one element, you have to create a node. So again I'm creating a node. So this is a base process. So I'm putting the element as usual, and of course the next will be null by default, and this will be stored as temp, right? This is our logic, right? And what is the condition we are going to check? I told you the very first condition has to be whether your head is null or not. All right, but look at this one. Unlike your previous iteration, your head is not null. Head has something because this is your head, right? So it has something. So what are we supposed to do when your head is filled? You are not supposed to directly store in head.next. You cannot say head.next is equal to this element. I mean your node. All right, you shouldn't do that, because you know very well there is a head. That doesn't mean there is only head. You might have some nodes beyond head. All right, like head is like one. Let's say like your first node is head. You might have second node, third node, fourth node, and it keeps going, right? So you don't know. All you can say is your linked list is not empty. When your head is having something, you can come to a point that your linked list is not empty. All right, doesn't mean it has only one element, I mean one node. So what are we going to do now? So let's assume a figure. Let's say your linked list has something like this, like some set of nodes. All right, as for now, your your linked list has three nodes. All right, just assume. All right, so what are we supposed to do when you want to add elements? You are supposed to add the newcomer in the sense like your new, the very new value which you're about to insert. Let's say it is like 8. So if you want to insert this node, you're supposed to insert this node as a next of this node, next of this very last node. It's just like if suppose you're standing in a row, you're standing in a straight line with like you're facing the back of the previous person. In that way, if someone wants to enter into the line, he's not supposed to get into the line or at the front of the line. He's supposed to stand at the last of the line. So in order to know that, he should know the very last person standing in a line so that he can go behind that guy. All right, so according to this diagram, this is first node, this is second node, and this is third node. So one thing you have to remember, your linked list will never have a size. No one knows how many nodes are there in your linked list. All you know that you have something called as head. If your head is null, then it's empty. That's different scenario. But if your head has something, you only know that you have some set of nodes. All right, but you don't know how many nodes are there. The only possible way is you have to traverse the node. Traversing is like from head you have to move to the next, because head knows who's the next guy, right? I told you every node will know its very next guy. All right, so one knows where 2 is. All right, so you're going to from 1 to 2. All right, now you are in 2. So does 2 has neighbor? Of course it has one neighbor. All right, which means like it's not null. If someone's next is not null, he has a neighbor. All right, so his next, 2's next has something. All right, so 2 has a neighbor, so you have to jump to that neighbor. Again, it's 3, you are in 3. So 3 has no neighbor because 3 dot next will be obviously null. All right, because anyone who remains be a last person, his next node will be null. All right, which means like if some node's next is null, you'll be having only one node whose next is null, because you'll be having only one last guy. You cannot have two guys standing at the last. No way. All right, so you can have only one guy who's standing at the last, and in order to find that guy, you can easily verify that next, that particular node's dot next should be null. If it is null, then you can easily come to a conclusion that he's the last guy. Alright, so 3 dot next is actually null. So now you can stop at 3. Alright, so you found that this is the last guy. So you can easily say the current node you're focusing, that is 3 dot next, is equal to the newly entered node. Who is the newly entered node? That is this one, this temporary, which we are creating whenever we are inserting something. So how are we going to traverse? Okay, so this is the logic which I told you, like, this is the way, this is a method through which you're going to insert. All right, so code wise I'll be using Java to explain, since that's something familiar with everyone, so most of the guys. All right, so I'll be using Java to explain this one, and I really hope that you understood what linked list is, like, like a basic concept, like how it is getting stored and how it is added, and all the stuff. All right, so now I'll be showing how to add this node using Java. So let's go back to NetBeans. Here it is. All right, as I told you, like there is no inbuilt data structure. There is no inbuilt data structure called node in Java or any other um, programming language. So you have to create it on your own. So node, you can name this class as anything, but node suits better. So I told you a node should have two things. What are the two things? One is, oh, my bad. All right. All right, so one thing is data. Data is of integer. The type of data is integer, so then you can set your own data type. All right, it's not necessary that it has to be an integer. It can be anything. And the next should be of type node. Of course it should be of type node, because next is always storing the next node, so it should be of type node. All right, so these are the two mandatory stuff which you should have in the node. And look at the constructor here. Int d, whenever you're going to create a node, I told you create node only when you want to insert some element. So this is the element, d represent data, so this is the data which you're going to put into the node. So you're passing the data, and by default whenever you create a node, your next of that particular node should be null. All right, because here you know very well he's going to be the last guy, so obviously that's next should be null. All right, so the one which is going to be the last, which means whenever you're going to put a node at the very last position, you know very well that that guy will be the very last guy, so you definitely can put this next as null. All right. Then coming back to this. All right. Okay. Coming back to this add method. All right. Look at this one. So as I told you, whenever you want to add something, the very first thing you need to do is like I was talking about temp, right? That's what I have given here. Instead of temp, I used a variable called new node. All right. So whenever you want to add some data, people will be calling this add method only when they want to add data. So very first thing you need to do is like just create a new node. Okay, with the data whatever user has given. From here I have taken the data, so I just created a new node. This is nothing but the temp which we spoke earlier. Then again here, and I also told the first thing you need to consider is like check your head is null or not. This is to make sure that your linked list is not empty. If it is empty, you can directly say that head is equal to new node, because this is a very first node, and obviously this has to be a head. All right, head is something which is common for a linked list. All right, head will not come under node. Please note this point. Look at this one. Look at this head. Head will be there will be only one head for the entire linked list, not for every node. All right, the first node of the linked list is called as head. Don't get confused. All right, so I'm checking the by default the head is null. That's what at the start of the programming, like I just made this point that head has to be null. And here I'm just checking head is null or not. When my head is null, I made sure that there is no nodes present in my linked list, so I can directly say head is equal to new node, so the node which we have just created. And that's it. We don't want to get into the else part because this condition is satisfied, so it will stop here. This is for the first iteration. First iteration in the sense like for the first time you're entering some value into that. Let's assume you're entering 20 for the first time. So when you're inserting 20, the next of 20 will be null, right? So this is a node. Consider this is a node. So as for now, head is this node. So head is this node whose next is null. So then again, I'm going to add 30 again. Let's suppose I'm going to add 30 again. So what I told you, so whatever it is, like you have to create the node first, node, and the next of that node will be null as for now. So I'm talking about this line. Okay, then again, I'm checking my head. This time my head is not null because my head already contains some node. So it's not null. So it's getting into the else part, and it says, look at this one. Node current is equal to head. Current current is a variable which is going to hold the current node. I told you, right? You're going to jump from one node to the other node. So from first node knows whether there is second node or not, and if there is a second node, you're supposed to jump from first node to second node. So current is a guy who is going to hold the current node. All right, so if you're jumping into the second node, your current will be holding node 2, and from 2 you'll be checking whether there is a third node or not. If there is third node, you'll be jumping to the third node again, and your current will hold third node at that particular time, right? So I have used while loop. The reason for using while loop over for loop here is it's very simple actually, because we don't know the number of nodes present in the linked list. So obviously we have to go for the while loop. So current dot next. Look at the condition I have given here. I give you note that if someone's next is null, he is the last guy. All right, every guy knows its very next guy. If at all you got a node whose next is null, which means he's saying there is no next guy. That for me there is no next guy, which means he is the last guy. All right, so the condition says current dot next not equal to null. If this condition is valid, which means there is one more guy beyond that guy. All right, so as for now current is head, so current is holding this node, and while condition fails here, look at this one. This current is actually holding this node, so this node dot null this node dot next is actually equal to null, because he is a head. Of course he is a head, and also he is a tail, which means he is the last node as well. All right, so it will not get into the while loop for this iteration, which means when you're inserting for the second time, it will not get into the while loop. So directly it's getting here current dot next. All right, current dot, what is your current? Of course this is your current. I told you I just made current as my head. All right, so this is my current. So I say current dot next is equal to new node. New node is nothing but the node which we have created, that is this node. All right, so current, so this node dot next, which means this value is going to point out the node which we just created. So it is no more null. It will be holding the address of this node. Let's assume this node is 1, this node is 1, and of course this is head 2. Let's name this as 1, and this is node 2, and so on. Alright, so as for now you have got two nodes. So first node will have the element as well as the address of the second node. It's not literally true, don't think in that way, just the address. For easy understanding, I just made this as 2 so that you will understand that this is a second node. Alright, so now we are done with this one, and third iteration we'll go for one more iteration. So I just want to insert 50. Alright, so as I told you, like, you'll be creating a new node. So again you'll be having this one, 50 comma null. Whenever you create a new node, your next will be null. Alright, so then again it checks for the head. Head is not null, of course. Head is this guy, so it's not null, so it's getting into the else condition. You say current is equal to head, so your current is going to stand here. Alright, you're standing in the first node. Then again you're using a while loop current dot next. You're checking your current dot next. This time your current dot next is actually not null, because you know very well this is data, this is next. Alright, so current dot next is focusing on some other node and it is not null, so the condition is valid, and we say current is equal to current dot next. What does that mean? Current is just a variable. Current is actually, as for now, this is a current, so I'm updating my current. Current is equal to the current dot next, which is 2 is nothing but this node, the address of the next node. So this way I'm jumping from first node to second node. So if you're getting confused with this line, I'll explain one more time. Look at this one. See, your current is standing here. All right, so current is standing here. Your current dot data is 20. Current dot next is 2. That is your address of the next node. All right, that is this guy. So what I say is, like, current is equal to current. I'm updating my current. Current is equal to what am I going to store in the current? The current dot next. What is current dot next? Current is this guy. Current dot next is nothing but the 2. So obviously 2 is going to get into this current. So this way I'm shifting my current to, now current is holding 2, right? Which means current is pointing out to this node. Okay, now again, while loop, the condition current dot next node equal to null. The condition fails because current dot next is actually equal to null, which means you just made it, which means, like, you are at the end of the node. You have set of nodes and you are at the very last node, because only for the last node you will not be having the next. All right, if you don't have next, that's the last node. I'm repeating this again and again. All right, so this is the only condition you can put on to get the last node. Okay, so now you're coming out of the while condition, while loop, and you're checking your current. When you're coming out of the while loop, obviously your current will be focusing on the last node, whether it is your second node, third node, whatsoever it is, like, it will definitely focus on the last node. So you can blindly say current dot next. Next is, like, you can update your current as your third node, the newly entered node. So let's say this is your third node, and here you'll be having 3. You're updating it here. Look at this one, current dot next is equal to new node. So this way you're making the link between these two guys. So only 2 knows where 3 is, only 1 knows where 2 is. Alright, 1 will never know where 3 is. 1 will even never know there is someone called 3. Alright, I'm sorry about that. Alright, so that's all about linked list, a basic understanding of linked list, and also how to add things into the linked list using Java. So in the upcoming videos I'll be uploading about, like, how to insert at a particular position, because, like, here insertion we are talking about only inserting at the last position. Alright, so if you want to insert at a particular position, I will teach you, and also, like, how to delete something in a linked list. All those things will be covered in the upcoming part 2 video. Alright, so thank you for looking into this video, and if you like my channel, please do subscribe and give a thumbs up for this particular video. Alright, stay tuned for upcoming videos. Thank you.